Hi everyone. This video presents the FHIR Terminology Services API and specifically the operations that this API offers. If you're interested in learning about the FHIR terminology resources, please check out the video on that topic that we also provide. The reason we're interested in terminology when we look at sharing clinical information is that terminology really is the basis of shared meaning when we're interoperating that information. Things like FHIR structure definitions or generally speaking, the information model are the skeleton of the information we're exchanging, but it's the terminology that's the muscles. That's where the real meaning lives. And terminology, and in particular value sets, is also a very important part of defining profiles when we're trying to customize an information model for use in a specific context, because it's where we narrow down the set of codes that are acceptable for use in that context. In a large integrated system, having a reference for terminology in a single place is very valuable for the purposes of interoperability, because all of the different parts of the system can agree on which code systems are being used and which versions of those code systems are being used. When it's possible to do so, externalized terminology also makes it easier to update the terminology so that we can be sure that when we roll out a new version, it's being rolled out once across all of those different parts of the system. So if we're using FHIR or indeed some other representation of clinical information, there's a bunch of different use cases where terminology and the Terminology Services API can help us. So for example, if we're doing data entry, then we want the users to be able to quickly find the right code or codes in order to enter that data into their clinical record for the context they're working in. From a validation point of view, if we receive a whole bunch of codes, we want to be able to execute some sort of check to see whether the codes we've received are appropriate for the context in which they're being used. For display and understanding, if we have a set of codes, we often want to explore those codes to look at what the hierarchical relationships might be between them, to look at what properties they might have. Mapping is a very important thing that we often need to do, whether it's mapping between clinically specific codes across to more analytics level codes, like codes for billing or codes for categorization according to some sort of data analytics task. If we are doing analytics, one of the first things that we often want to do is to arrange our coded data into different categories so that we can try to break down what's happening in the data. If we're doing authoring, we might need to make our own code systems, value sets, and concept maps to support some of these other tasks that we're carrying out. And if you're interested in authoring, again, I'd urge you to check out the video that we've done about the FHIR terminology resources, the code system, value set, and concept map resources, as well as the videos that we have on our Snapper lightweight authoring tool. And finally, if we're building a server for clinical information, such as, for example, a FHIR server, then we often want that server to be able to be smart about terminology. So for example, being able to perform terminology-aware search, where we find not only all procedures that have a certain code, but all procedures that match a certain code. So they might be subcodes according to the hierarchy of the code system that we're using. So when we're using terminology in the context of FHIR specifically, there are three data types that we see in the FHIR resource definitions. The first of these is the code data type, and a code data type is by far the simplest in that it just gives us a code. It doesn't specify which code system the code is coming from, and that's because that code system is fixed by the definition of the resource that we're using. So if we're looking at something like a gender element on the patient resource in FHIR, then we don't have to provide a code system URL when we're defining that gender element because it's fixed by the patient resource definition itself. The second data type is the coding data type. So with a coding data type, in addition to the code, we have to specify that code system URL. And we can optionally also specify the version of the code system that we're using, what the display term is for the code that we've chosen, and whether it's been selected directly by the user, or perhaps it's been mapped or something like that. The third data type we'll see, and this is by far the most common data type in FHIR, is the codable concept data type. And codable concept allows us to specify multiple codings as well as a textual representation of the code. When we're using the FHIR search API, the search parameter type that we're going to use for terminology data is the token data type. And so that gives us 4 syntaxes that we can use for specifying the search parameter that we want to use. If we can put the code system URL followed by a pipe and then the code, then we want both of those things to match. If we just put the code with no pipe or no code system URL, then we're saying we can match any code that matches that, regardless of which system it's in. We can put a pipe and then a code, which is a bit of a derivative case where there is no system specified. And then we can also specify the system and followed by a pipe character without any code. And that means that will match any code in that code system. When we're using this token search parameter type, there are also some modifiers that we can use. The text and "not" modifiers work the same way as they do with all of the other FHIR search parameters. :below and :above allow us to search the hierarchy of the code that we provide. So instead of saying code equals 1, 2, 3, 4, 5, we can say code :below equals 1, 2, 3, 4, 5, and that will match that 1, 2, 3, 4, 5 code as well as any of its descendants according to the code system's hierarchy. Using the :in and :not in modifiers, we can pass in a value set URL and search for any coded element that is a member of the value set that we provide. And there's also a :of type modifier, which is specifically for use with identifier search parameters. So just as an example of how some of these show up in a FHIR resource, this is a fairly simple piece of JSON for an encounter resource. The first element that we can see in there is a status element, which has a value of in progress in this case, and that's a code typed element. So it doesn't specify which code system that code comes from, because that is clearly defined by the definition of the encounter resource type. So it can't be varied. The class element, which we can see is the second one in this resource, is a coding typed element. So in this, we've chosen to specify a code and also to specify the code system URL. So both of those are mandatory. We could also have specified the version of the code system, the display term of the code, and whether it's user selected. The third element we see here is a reason code element. This is a multi-valued element, so there's an array of codable concepts in it. And within this particular codable concept, we can see we've included 2 coding values. The first is a SNOMED code. In this case, we have specified the version and we've specified that user selected is true. So this was the code that the user selected when they were entering the data. And the second coding in that codable concept is an ICD-10 code. So perhaps that's been a code that's been mapped across according to some mapping. And this codable concept also specifies a text representation as well, suspected COVID-19 in this case. So when we're looking at the FHIR terminology resources, just as a quick summary, the 3 we're looking at are the code system resource, the value set resource, and the concept map resource. And the N symbols on this diagram indicate that the code system and value set resources are now normative resources in the FHIR spec, as of the R4 version of the FHIR spec, which means that they're very unlikely to change at all, and you can build with safety with those resources. The concept map resource, on the other hand, is currently at maturity level 3, which means that there is some chance that some of the parts of concept map will change, even though it has been through some HL7 connectathons and it has had a degree of scrutiny from the FHIR community. So what are these resources? The code system resource allows us to specify a set of concepts with some coherent meaning. Sometimes this will be standardized code systems like SNOMED CT or LOINC or ICD-10, and sometimes it'll be bespoke or proprietary code systems that we're defining ourselves. And within a code system, we'll have a bunch of metadata. Chief among those is a URL and a version. Those are important because they are what we use to refer to a code system from other resources, like when we're putting together a value set. There's a lot of other metadata, things like the name of the code system. Then we define filters and properties that are available on this code system. And most importantly, we define what the concepts are in this code system. And for each of the concepts, we can define a code, we can define a display term, we can provide a definition for that code, we can provide a bunch of designations for that code, which might be synonyms or they might be language translations. So that's a code system. The second resource is the value set resource. So a value set resource is a set of codes that's useful for some context, where those codes are drawn in from one or more code systems. So it's quite common to populate a value set based on codes from a single code system, but it is possible to import codes from multiple code systems. And we can do that importing either by providing a specific list of codes that we want to include, so defining that value set by extension, or we can use rules to define which codes are included in the value set, so we can define it intentionally. The third resource that's relevant for FHIR terminology services is the concept map resource. And concept map gives us a fairly simple way of defining a mapping from codes in one value set to codes in another value set, where each of those mappings that is included in the concept map consists of a source code, a target code, and the relationship that holds between those. So that might be that the two codes are equivalent, or that one is broader than the other, or that they're just related to in some unspecified way. If you're interested in more detail about the FHIR terminology resources themselves and what their structure looks like, then please do check out the video that we've provided on the FHIR terminology resources. So just by way of a little bit of background of how FHIR works for manipulating these resources, the basics are that there are a series of interactions that are possible. The most common of these are what are called the SCRUD interactions. So search, create, read, update, and delete. So this allows us to maintain those resources on the server by sending through requests using the HTTP verbs get, post, put, or delete. What we're really interested in this video, though, is the operations that are defined on those resources. And we can invoke these in a variety of ways. So for operations that are idempotent, so where you can make the same call over and over again and always get the same result, then we can use the HTTP get method. And that has the advantage that it can be cached by servers that we're using. And some of the operations will allow us to invoke that operation at the root level of the FHIR server. Some will be at the resource level of the FHIR server, so slash, for example, value set slash $expand, or at the resource instance level, where we're interested in invoking the operation on a specific resource. Where we want to pass in parameters, if we're using a GET request, we can pass them in just as URL parameters. Or if we're using a POST request, we pass them in as a FHIR parameters resource in the body of that POST request. So the first scenario that we're going to look at for exploring these FHIR terminology service operations is the scenario of data entry. So we've got perhaps a clinician or a patient or some sort of data analyst who's providing some sort of input, and we want to allow them to choose some coded values as part of that data input activity. The first thing that we're going to want to do is choose our code systems that we're going to use. Hopefully we might be able to use standardized code systems like SNOMED CT or LOINC or some official data dictionary code systems, but maybe we'll have to define our own code systems. Once we've done that, we can define the value sets by identifying which codes from those code systems we think are in scope for the data entry activity. And if that value set ends up being small, we might represent it as a pick list or a drop-down menu or radio buttons even, and we can work out what those options are using the expand operation. On the other hand, if our value set is large, so for example, if we're allowing a pharmacist to choose a medication for dispense or a GP to choose a presenting condition, then we're more likely to use a type ahead widget. And in this case, we can still use the expand operation, but we're likely to use it with the filter parameter, providing some text filter. So if you want an illustration of how the expand operation works, this SNOMED terminology user interface demo is a good example of that. It has notes on it that explain how it's using the expand operation for a bunch of different fields that you might want to use it for in a clinical data entry scenario. And it's pointing, I think by default, it points to the SNOMED International snowstorm server, but it can also be pointed at any conformant FHIR terminology services implementation, including Onto server. So I'd encourage you to explore that. So that first operation then is the expand operation. And the way that expand works is that it allows us to retrieve the expansion of a value set subject to a number of parameters. So some of the parameters that we might pass in are the URL of the value set we're interested in. Or if not the URL, then maybe we pass in the value set using a value set parameter. That allows us to do dynamic value set expansion. Or perhaps the context. So perhaps we don't know what value set we're interested in, but we do know, for example, that it's the medication.code element in the FHIR model. So in that case, we can use the context parameter. We can pass in a text filter, which allows us to narrow down the codes that come back based on some sort of user input, typically. We can use count and offset to page through the results. So for example, to specify that we only want the first 10 results, or that we only want the next 10 results after the first 100. And then we can pass through some parameters that change the form of the value set that comes back as the expansion value set, with things like include designations, which is a parameter that allows us to make sure that designations come back in the expanded value set, include definition to make sure the logical definition of that value set is provided, active only to ensure that we only get active codes, or display language to say, for example, that we want UK English results, or we want Italian results, etc. The expand operation can be invoked either at the type level by providing a value set using the URL context or value set parameters, or at the instance level if we want to really be specific about which value set we want. And so the expand operation really is the main and the best way to search for a code that we have in the FHIR Terminology Services API. So here's a first example of doing this. So in this case, I'm going to call the expand operation, and I'm going to pass in the URL of the value set I'm interested in. And in this case, it's the FHIR administrative gender value set. And I'm not going to pass through any other parameters, but I am going to say that I want FHIR JSON back. And so what I get back is a value set that has this expansion element populated. And it comes back and it'll tell me how many codes are in that expansion. It'll tell me what parameters were used in the calculation of that expansion. And then it'll show which codes come back. And again, because value sets can include codes from multiple code systems, each of the codes that comes back in that expansion will tell us which code system it comes from. So in this case, they all come from the FHIR administrative gender code system. And so we can see these 4 codes have come back from that code system. The second expand example allows us to see how we use a text filter in our expansion. So in this case, I'm going to call the expand operation, and I'm going to provide the URL of all of the codes in the LOINC code system. So that's actually an implicit code system value set URL, and I'll get to what those implicit value sets are later on. And I'm going to pass in a filter saying I want codes that somehow match the text filter urinalysis. And it's actually up to the server how it interprets that. So whether it does prefix matching or whole string matching or some other sort of heuristic. And I'm also going to say I only want to see the first 3 results. So what comes back, surely enough, is a value set with the expansion element populated. It tells me that there were 52 codes that matched this, but I did pass in a count parameter of 3. And so I can see that the top 3 results have come back here. So this first one was an exact match on the text filter, so it's come back first. And these other terms have matched one of the words exactly, so they've been ranked quite highly as well. The order that concepts come back in an expansion result is actually up to the server. So some servers will order those differently depending on what they think is the most useful order to the person using the API. This next example shows how to use the value set expand operation using the context parameter instead of providing the URL of a value set. So in this case, we're going to say we want to expand whichever value set is bound to the status field in the medication resource. So when we get our result back, the expansion element actually includes a parameter that says, well, this is the value set that I expanded. So when I looked up that medication.status element, this is the value set that was bound to that. So that's the value set that I've expanded. And it comes back and it shows these 3 codes that have come back from that expand request. So the next context of use that we're going to look at is analyzing and validating coded data. So this is useful if you receive a dump of some data with a bunch of columns, perhaps of coded data, and you want to see whether the values in those columns are actually acceptable for that context. So you want to detect cases where someone's provided you a medication when you were expecting a procedure, or someone's provided you a condition code where you were expecting a gender or something. And the operation we can use to do that is the validate code operation. And when we are receiving data like this, there's probably some other operations we'll want to use as well. So we could use translate to map foreign or proprietarily coded data into some sort of normalized form. We could use the subsumes or the closure or again, the validate code options with an inline value set to try and categorize that data as well. And we'll get to some of those operations later in the video. So the first and most important operation for this context is the validate code operation. And validate code allows us to take a code and to take a value set and to determine whether the code is a member of that value set. And as a bonus, if we also receive the display text for the code, we can also check whether that display text is an acceptable display text for that code in the context of that value set. So to do that, we can either use an existing value set by passing in the URL of that value set, or using an instance level invocation of the operation, or we can post in a value set as part of the request. The code we can provide either as a code system version combination, or as a coding, or even as a codable concept. What the operation then will do is it'll determine whether the code is included in the value set, and it'll give us a Boolean result for that. And if we do provide display text, then it'll tell us whether that display text is a correct display text for the code, keeping in mind that codes can have multiple acceptable display texts. So this is the main method that we can use for validating coded data and its membership in a value set. There is also a corresponding operation on the code system resource that doesn't check whether the code's in the value set, but it checks whether the code is a valid code in the code system itself. So here's an example of validate code. In this case, I'm calling the operation using an implicit value set URL. And again, we'll get to what those are later in the video. And this implicit value set URL is the set of all codes in SNOMED CT. To be honest, for most real use cases, you would never use such a broad value set to validate against, but we can for this example. And the code that we want to check whether it's a member of this value set is this SNOMED code. So for each time we use validate code, we have to tell it both the system and the code of the code that we're interested in. Again, since value sets can include codes from multiple code systems. And it's this 383.62002 code. And when we send that request through to the server, it comes back with a parameters resource as the result. So the result will tell us that, yes, this code is a member of the value set all of SNOMED. And just for convenience, it'll tell us that the display term for that code is dengue fever. Another example of the validate code operation here. So in this case, once again, we're going to use the value set all of SNOMED. And we're going to pass in a SNOMED code, in this case 136440009, and the display term that we've been provided with for this code is hypercholesterolemia. And when we send through this request, the server will come back and it'll tell us some more information. So it'll give us a result false, and it'll, in our message parameter, result parameter down here, it'll say that the code exists in the value set, but the display that you provided is incorrect. And for convenience, again, it has given us the correct display. So in this code system, hypercholesterolemia has an AE here at the end. and the string that we provided just has an E, so it's not an acceptable display text in this case. So the next scenario we'll look at then is the kind of exploration scenario. So when we're interested in a bunch of codes, one of the first things we want to do is to see how they relate to one another and to retrieve information about those codes. So the ways that we can do that, we can use the lookup operation to retrieve the properties of a code. And this allows them to, for example, display them in a table. And maybe some of the particularly interesting properties of a child and parent properties, which tell us about hierarchy. If we are interested in hierarchy, we could also use the subsumes or closure operations to explore that hierarchy that exists between those concepts. So if you're interested in this kind of scenario, a good example to look at is the Shrimp terminology browser that's publicly available. It was originally a SNOMED CT browser, but today it's a generic FHIR code system browser. So it uses the lookup operation and the subsumes operation and a bunch of other FHIR terminology service operations to show the relationships between a set of codes and a lot of their properties. So for example, that table in the bottom right-hand corner shows the properties of the focus concept, in this case, pneumococcal pneumonia. So the lookup operation then is the main way of doing this. It's a very simple operation. We pass in a code expressed either as a code with a system and a version or just as a coding element. And the server will come back to with all the properties and designations and details about that code. So as an example, in this case, I'm going to do a lookup on a code from a proprietary code system that I've defined myself. This is a code system for all of the Australian jurisdictions. And I'm going to ask for information about the WA code. So when I send that through, I can see I get a parameters resource back in my response. It has some information about the code system. So it'll tell me the name of the code system and its version. It'll tell me that the display term for the code is Western Australia. And in this case, it's got a designation. This is the SNOMED code for a synonym. So it tells me that this designation is a synonym. So West Australia is a synonym for Western Australia. And it has a parent property, which is AU state. Now, if you've seen the FHIR terminology resources presentation, you might recall that this code does actually have some other properties. And it's a characteristic of the lookup operation that the operation is not guaranteed to return all properties. So it's actually up to the server which properties it chooses to return to you, unless you use the property parameter to specify that you specifically want to see certain properties. The next operation we're going to look at is the subsumes operation. So subsumes is another fairly simple operation. It allows us to pass in two codes, code A and code B. Once again, we can provide these either as a code and system or as codings. And the server will tell us what subsumption relationship, if any, exists between those two codes. So the four possible results that we could get for that relationship or non-relationship are that the two codes are equivalent. And that's very useful if you've got a code system that supports post-coordination, for example. That code A subsumes code B, that code A is subsumed by code B, or that there is no subsumption relationship that the server knows about code A and code B. So here's an example of that. So we're going to pass in this subsumes request to the server. The system for the request, both codes in a subsumes request have to come from the same system, so we only have to provide that once. We're going to pass in two SNOMED codes, and in this case, I think this is body parts and hand, or two body parts that do have a subsumption relationship. So when we make that request, the server comes back and says, the result of this operation is subsumes. So code A subsumes code B. We might just take a break here to talk about some of the well-known terminologies. So one of the characteristics of the FHIR spec when it comes to terminologies is that some of the really well-known terminologies like SNOMED CT, like LOINC, like ICD-10, like the units of measure code system, have specific mappings into FHIR terminology resources. with standardized code systems. So these code systems fix what the URL is for that code system. They fix the format that's used for the versioning of that code system. They can define standard code system filters and properties that should be available for that code system. They can define implicit value sets for that code system. And they can also define implicit concept maps for those for that code system. And what that means in practice is that when we, for example, add a SNOMED CT code system into our server, there are a whole bunch of value sets and concept maps that just exist in the server automatically without us having to actually post or put those ourselves. So just to provide some of the examples of this, SNOMED CT here on the left, the URL for that is snomed.info/sct. And the version syntax for SNOMED CT is actually quite a long one. It's that base URL snomed.info/sct/the edition. So for example, this might be the concept ID for the UK edition of SNOMED, which is 838 something or other 107, /version/date. So 2020-09-30 or something like that. The properties that are defined for SNOMED CT include all of the relationships in SNOMED CT. So things like has active ingredient or finding site or procedure site for conditions or procedures. The normal form for a concept is another property you can retrieve, as well as the module ID that contains the definition of that concept. The filters that are available for SNOMED CT, all of those relationships are available as filters as well. Subsumption is available as a filter. So concept ISA allows us to find all of the concepts that are descendants of a certain code. Membership of a ref set is available as a filter, as are ECL expressions. So the expression constraint language is a very expressive way of constructing queries over the SNOMED model that allow you to very precisely narrow down a specific set of concepts that you're interested in. SNOMED CT comes with a bunch of implicit value sets. The first of these is a very simple one. It's the set of all codes in SNOMED. So if we use that value set URL, then that will work as if we had constructed that value set ourselves of all codes in SNOMED CT. We can construct these URLs as well by subsumption. So if we say, if we use this value set here that ends in FHIR equals ISA / and then some code, that will represent the value set of that code and all of its descendants according to the hierarchy of the code system. We can retrieve the list of all available ref sets using this FHIR equals ref set implicit value set. We can retrieve all of the codes in a ref set using this FHIR equals ref set / the ID of some ref set. And then we can find the value set of all codes that match an ECL expression by just appending that ECL expression on the end of a URL of this form here. So FHIR equals ECL / something. SNOMED CT also comes with implicit concept maps. So in the same way that these value sets exist without us having to define them, the concept maps corresponding to SNOMED's historical associations also exist without us having to define them, just by using this URL pattern. So this pattern that ends in FHIR equals, and then the ID of one of the historical associations ref sets. And this allows us to find for a retired code, what are the codes that it's been replaced by, or the codes that are the same as that code, etc. The same sort of thing exists for the LOINC code system. So we can retrieve the access properties like time, aspect, and method, and property, and so on for all of the LOINC terms. The status allows us to find which codes are deprecated. We can construct filters by the multi-actual hierarchy, as well as by part. LOINC comes with a few implicit value sets. So once again, the all codes implicit value set is defined, ending in /vs. We can use implicit value sets for the multi-actual hierarchy by putting the code of a specific LOINC part at the end, and that will represent a value set containing all of the codes that descend from that LOINC part. And then finally for LOINC answer lists. So if we use a value set URL of this form here, then it will give us the value set of all of the answers for this particular answer list. So all of the answer codes for that answer list. So returning to our contexts of use, the next context we're going to look at is the mapping context. So there's lots of reasons why we want to build maps between value sets. So we might want to map clinical codes across to administrative codes. We might want a migration map for mapping legacy codes across to some new normalized code system. Or any other sort of purposes. We may want to map codes up to some sort of analytics category, for example. And the way we do this is, first of all, we build a concept map, or perhaps there'll be one off the shelf that we can use, and then we use the translate operation. So the translate operation allows us to interrogate a concept map and to find what codes are mapped to by that concept map. So most of the time, that's a fairly simple case of looking up the rows in the concept map and displaying the ones that match. But there are some slightly more complex things involving the unmapped element of a concept map as well. The codes we're interested in mapping are passed in either as a code system inversion or a coding or a codable concept. And when we do that, we specify the source and or target code system, and we can specify the target, the source or target value set, and we can specify the target code system as well. It is possible to run the translate operation in reverse, but it shouldn't be confused with interpreting the map as a bidirectional map. So it's important that you think of using the reverse parameter on translate as asking the question, what codes map to this code? It's not what codes does this map back to. So it's not really a reverse invocation of the map. It's asking what codes map to this. When we run the translate operation, the result comes back as a parameters resource with different match elements. So we'll see an example of that now. So this is an example using the implicit concept map that comes inside SNOMED CT for inactivated concepts. And that's this URL here. And the target code system, the target value set that we're interested in this case, we're just going to say it's all of FHIR. And the code that we're passing in is a SNOMED code, and it's this 399.144.008. And when we send that request through to the server comes back with this parameters object. It says, yes, I did find a match in the concept map for the code you passed in. And then it has this match in the match section. There's only a single part in this case, a single match in this case, and it says that the two codes that came back are, the code that comes back is equivalent. And this is what it is. So it's this code for diabetes mellitus co-concurrent and due to hemochromatosis. It also comes back and tells us that the source of that map is this specific version of that concept map, which is useful if it's possible that multiple concept maps might be potentially used. So the next example we're going to use, if we're going to perform more advanced analytics, or perhaps if we're going to try to integrate our FHIR server with a terminology server, then one of the operations we might want to use is the closure operation. So the closure operation works a lot like the subsumes operation in that it allows us to interrogate the hierarchy relationships that exist between different codes, but it allows us to do this by building up a table of codes over time. So this happens in a number of steps. So the first step is that we create an empty closure table. Then we add codes either one by one or in batches. And each time you add codes, the result of the operation shows you the new hierarchical relationships that exist between the set of codes as a result of your addition. This is a stateful operation, so the server does store the state of your closure table as you're going along. And one of the consequences of that is that it is possible for the server to forget your table. And so sometimes the result that comes back from a closure request is a matter of saying, I don't know anything about this closure table anymore. So if you're a client using the closure operation, you do need to be able to start over from scratch at times. And this closure operation is a really good way of querying code hierarchy without having to hit the server every time you want to ask a question about the hierarchy in a code system. So here's a series of steps illustrating the use of a closure table. So in this first step, we're going to create the closure table. So we send through a request with a parameters resource. And in that, we just give it the name of the closure table we're interested in for this first step. And the server comes back with a concept map resource. We can see that it's version 1, so we know that this has just started. We can see its name. And in this case, we can see that there's no other information about the hierarchical relationships between codes. We'll see some of those as we go along. Some of those will start to appear. So in the second step, we're going to add in another code. So we're going to pass in another parameters object. We're going to use the same name for the closure table, so the server knows that we're adding which closure table we're adding a code to. And we're going to add in the hand structure code from SNOMED CT into our closure table. And when we do that, the server comes back. It sends us back another concept map. This is version 2 of the concept map, so we know that that's progressed. And that's an important way of knowing that the server hasn't forgotten our closure table, is that that version is incrementing the way we expect it to. And again, it hasn't added in any relationships. There's only one code, so there's no hierarchy relationships between one code. In this next step, we're going to pass in 2 more codes. So we're going to pass in, once again, a parameters resource with the name of our closure table. And we're going to pass in the entire toe concept and the limb structure concept, in addition to our hand structure that we already had in there. And when we do that, the server comes back. It comes back with a concept map. I've broken up this concept map into 2 pieces because it's a bit big. And we can see that it's version 3 of the concept map. And we can see that it now has this group element. So if you've watched the FHIR Terminology Services resources video, you'll understand that group is how concept maps organize the mapping rows so as to avoid repeating the source and target code systems. So this tells us that in this group, the source and target codes are both SNOMED CT codes, which is what we would expect for these relationships. So in the second part of this concept map resource, we have this element structure. And this shows us the actual mapping rows that exist in our concept map now. So what we can see is that the 855 concept here, which is our hand structure, now has a hierarchical relationship. And when we're reading concept maps, it's important to remember that the equivalence relationship reads from target to source. So in this case, what we're seeing is that the limb structure concept subsumes the hand structure concept. And there's also another relationship which says that the limb structure concept also subsumes the entire toe concept. And then in subsequent iterations, we can then continue to add codes. And in each case, it will show us the new hierarchical relationships that exist, including the transitive hierarchical relationships. So the final topic I'll just touch on very briefly is that case where we're trying to integrate some sort of clinical data repository, perhaps a FHIR repository, perhaps some other kind of clinical data repository with a terminology server to provide terminology-aware search or validation. So this allows us to do things like support searches of conditions where the code is below diabetes. So show us not only all of the diabetes conditions, but all of the children of diabetes as well. So show me all the type 1 diabetes, show me all the type 2 diabetes and all of the others as well. Or things like show me all of the procedures where the code is in this value set that I've constructed with this URL that I'm giving you. So when we're doing this, we've got a bunch of options. One of the options is to call the FHIR options that I've just been describing, including the closure operation, which is one of the first ones that you tend to look for when you're doing this integration. That's a fairly easy way to do the integration. It may or may not be performant depending on the scale of data, the frequency with which it changes, and what sort of performance requirements you have on your clinical data repository. Another option is to build virtual tables in your database. So tables that talk to the terminology server and keep cached copies of the parts of the terminology knowledge that you're interested in for your purposes. That has the advantage that the database can handle caching for you. So all of these terminology service operations that I've been describing are cache aware, so they do support caching. Another possibility is to maintain local caches of value set membership. So each time you have a new code that's added into your data repository, you can check whether it's a member of the value sets that you're interested in. That's quite efficient, but it doesn't deal with dynamic value sets. So if you're expecting someone to come along with a new value set at any point, then you might find that it's inefficient at that point to check whether the code is a member of that new value set. And you can also build hybrids of these approaches as well, depending on which parts of the terminology operations you need to be performant for different sort of user interactions. So that's all of the presentation that we have on FHIR terminology service operations. If you're interested in the resources that these operations are defined on, so the code system, value set, and concept map resources, then please do check out the video that we have on FHIR terminology resources. And if you do have any questions, then please feel free to send them through.